Imagine discovering that the Big Bang wasn't the beginning of everything. Imagine learning that our entire universe could be just one chapter in an infinite cosmic story, or perhaps only one bubble floating among countless invisible universes. These aren't science fiction fantasies. They are two of the most profound scientific ideas ever proposed, and they challenge everything we think we know about time, space, and reality itself. Stay with me, because by the end of this journey, you may never think about the universe the same way again. Close your eyes for a moment and imagine that everything you know, the stars above you, the earth beneath your feet, every memory you've ever made, and every second that has ever passed, is only a tiny fragment of a far greater reality. Now imagine something even more astonishing. What if the universe wasn't born just once? What if the Big Bang was not the absolute beginning, but either one event among countless universes or simply the latest chapter in an endless cosmic cycle? These ideas may sound like science fiction, yet they emerge from some of the deepest questions in modern physics. They challenge the very meaning of beginnings, endings, and even time itself. For centuries, humanity has searched for the ultimate origin of existence. We have looked to philosophy, religion, and eventually science for answers. The discovery of the Big Bang transformed our understanding of the cosmos, revealing that the universe has been expanding for billions of years. But every great scientific answer gives birth to an even greater question. If the universe had a beginning, what came before it? And if nothing existed before the Big Bang, how could something emerge from nothing? Today, we stand at the edge of one of the greatest intellectual debates of our time. Two remarkable ideas attempt to explain the mystery. One suggests that our universe is just one among an unimaginable collection of universes, each with its own history and perhaps even its own laws of physics. The other proposes that the universe never truly began at all, but has been renewing itself through an eternal sequence of cosmic ages. Before this journey ends, you'll discover why the answer could completely redefine humanity's place in reality. To understand these two extraordinary possibilities, we must first accept that infinity can take more than one form. One vision suggests that our universe is not unique, but part of an immense cosmic landscape. In this picture, the rapid expansion that occurred just after the Big Bang may never have completely stopped. While inflation ended in our region of space, allowing galaxies, stars, and planets to form, it could have continued elsewhere, constantly producing new regions of space. Each of these regions would become its own universe, separated from the others by distances so vast that they may never interact. Some could resemble our own, while others might operate under entirely different physical conditions, making reality far richer than anything we can directly observe. The second vision approaches infinity from a completely different direction. Instead of imagining countless universes existing side by side, it imagines a single universe experiencing an endless sequence of cosmic eras. According to this idea, the distant future of one universe gradually transforms into the beginning of another. As stars burn out, galaxies drift apart, and black holes eventually disappear, the universe becomes so smooth and empty that the distinction between an infinitely large future and an incredibly small beginning begins to lose its meaning. In this perspective, what appears to us as a new Big Bang may actually be the continuation of a universe that came before. These two visions ask profoundly different questions about existence. Is reality endlessly branching into new universes beyond our reach? Or is the cosmos engaged in an eternal rhythm of death and rebirth? Both seek to explain the same mystery, yet each paints a radically different portrait of infinity, challenging our deepest assumptions about time, space, and the true nature of reality. After exploring these two remarkable visions of the cosmos, one question naturally rises above all others. Which one describes the universe we actually inhabit? The honest answer is that no one knows with certainty. Despite extraordinary advances in astronomy and physics, the universe still guards many of its deepest secrets. Scientists are not simply debating abstract ideas, they are searching for measurable evidence that could reveal which explanation, if either, reflects reality. One of the most important places to search is the cosmic microwave background, the faint glow of radiation left behind by the early universe. It acts like a snapshot of the cosmos in its infancy, preserving subtle patterns that may contain clues about its earliest moments. Some researchers believe these patterns could support the idea of cosmic inflation, while others have searched for unusual features that might hint at traces of a previous cosmic age. So far, however, the evidence has not delivered a final verdict. Every new observation answers some questions while raising even more. This uncertainty is not a weakness of science, it is its greatest strength. Science does not begin with certainty, it begins with curiosity, testing ideas against nature and allowing evidence, rather than belief, to decide which explanations survive. The history of discovery has repeatedly shown that the universe often turns out to be far stranger than our first assumptions. Perhaps future telescopes, more precise measurements, or entirely new theories will reveal whether we live in one universe among countless others, or within an eternal sequence of cosmic rebirths. Until that day arrives, the mystery remains open, inviting us to keep questioning, keep exploring, and remember that every great discovery begins with the courage to ask what seems impossible. Perhaps the greatest lesson from this debate isn't which theory ultimately proves correct. It is the realization that the universe is under no obligation to match our intuition. Whether reality consists of countless universes stretching beyond imagination or an eternal sequence of cosmic rebirths, both possibilities remind us of how small our certainties truly are. Science advances not by protecting old answers, but by asking better questions. Somewhere in the faint glow of ancient light that still fills the cosmos may lie the evidence that settles this remarkable debate, or perhaps reveals an entirely different reality that neither theory has imagined. Until then, the universe continues to invite us to wonder, to question, and to explore. And perhaps that endless pursuit of understanding is the most extraordinary story of all.